Hey guys, Mr. Bowman here. Today's learning objective is in green and we are learning to calculate the volume of composite shapes. So this learning objective is an extension of the area version, except we now just want to slightly twist our thinking into the volume equivalent. We know what a composite shape is. So a composite shape is a bigger shape that comprises of multiple shapes put together. And the best way to understand these types of questions is let's just get into some. So we're going to start off with our rectangular, our L-shaped prism. And it is a prism because I'm drawing some dots along here. All those lines are parallel lines. So that means my prism formula will hold true. So the volume is going to be equal to the area of the face times the depth. So the depth is fairly easy. I know the depth is going to be 12, but the area is going to be a bit trickier. So what I'm going to do is I'm going to chop up area. So here's our face. It's this L shape here, and I've chopped it up into part number 1 and part number 2. The area of the smaller part is going to be base times height because that's a rectangle. We don't have this measurement on the top, but we have the big measurement along the bottom, which is 15, and a smaller measurement at the top, which is 8, leaving us 7 centimeters along here. And we do have that height because that height will be the 4 centimeters from the other side. So area number 1, so I suppose our equation would be the area of number 1 plus the area of number 2 times 12, which we already figured out to be the depth. Area number 1, base times height, that's going to be 7 times 4. And we now need to do the same for part number 2. We've got 10 by 8, so that's fairly straightforward as well. So 10 times 8, and then we're going to times that by 12. Let's go ahead and calculate that. So we've got 28 plus 80 times 12. We've got 108 times 12. And this is where I'll grab out my calculator to make sure I don't do any silly math errors. 108 times 12, that's going to get me to 1,296 centimeters cubed. So if I had a little cube that was 1 centimeter by 1 centimeter by 1 centimeter, I'll be able to fit 1,296 of those cubes into my shape. So we've done question number 1. We're now going to move on to question number 2. And the first thing to note, this is not a prism. So I don't have those parallel lines that were really evident. I'm circling them in the first question. So I don't have those. So our approach is going to have to be different. I'll start off by just doing a simple generic equation. So the volume of this shape is going to be equal to the volume of part number 1, which is going to be the curved bit at the top, and the volume of part number 2, which is going to be down the bottom. And we've now got to think a bit more about the shapes that we've got. So what exactly is 1? What exactly is 2? So 1 looks like a half sphere. So if you think of this maybe as a giant ice cream cone, it's got a half sphere on the top. And we'll carry on down. So forgive me about my equal signs aren't in line, but that's going to be 1/2 of 4/3 times pi r cubed, because that's the volume of a sphere, and I've times it by 1/2 because I've got half of 1. And I'm then going to add the second part, and that's a cone. And hopefully you recall that that's going to be 1/3 of pi r squared. So I've got my 2 formulas. I'm now going to quickly simplify that fraction stuff up the front. So that there is going to be 4/6, which would become 2/3. So we'll get rid of that. 2/3 of pi r cubed plus 1/3 of pi r squared. And I guess the big question here, oh gosh, actually I forgot, pi r squared times height and then times height. So the big question is, what exactly is r? So in our case, r stands for the radius, and that'll be the 6.5. Don't get confused by the diameter down the bottom. And the height, well, that's fairly easy. Height of the cone, 18. So let's substitute that in. So we're going to have 2/3 times pi times 6.5 cubed plus 1/3 times pi times 6.5 squared, and we're going to go times 18, So this is going to be really messy. Definitely grab your calculator out for this part. And hopefully you're getting 1,371.6 meters cubed. And that there had a 1 dp rounding. So guys, this is a short video on how to find the volume of composite shapes. Just a reminder, if you're working backwards for one of the dimensions, you will need to go through this process where you set up your equation, substitute in the volume and anything else you know, and then solve for those unknown things. Thank you so much for watching, guys. Hopefully you saw Chancey or at the top. See you later on.